Hello everyone, welcome to my channel. I am still looking at integration, and in this video I have this integral to look at. It's a definite integral. We have to evaluate the integral from 0 up to 1 of x to the power 6 minus 1 all over x to the power 4 plus x to the power 3 minus x minus 1 dx. Now, what technique of integration are we going to employ here? Well, looking at u substitution, we realize that if we let u be equal to the denominator differentiating, it doesn't give us that. If you let u be equal to the numerator differentiating, it doesn't give us that. That means we cannot use u substitution in this one. So we have to use other techniques. The first thing we have to look at is we have a difference of 2 squares in the numerator. We can start from there by factorizing that. This expression here also factorizes. If you look at this term and that term, these two terms have a common factor of x cubed. And there's a common factor of minus 1 there. So we can start from there and let's see what we get after that. So we have the integral from 0 up to 1 of x to the power 6 minus 1 all over x to the power 4 plus x to the power 3 minus x minus 1 dx. So what I was saying is this is the same as the integral from 0 up to 1 of, remember, difference of 2 squares. We have to say x to the power 3 plus 1 and then x to the power 3 minus 1. Remember, the square root of x power 6 is x power 3 and square root of 1 is 1. In the denominator, we have a common factor here and there. So we have x to the power 3, open brackets. X to the power 3 into that, the answer is x. X to the power 3 into x to the power 3, the answer is positive 1. And we have the common factor on the other side as minus 1. Minus 1 into that, the answer is x. Minus 1 into minus 1, the answer is positive 1. And then we have dx. Now, moving forward, this is the same as the integral from 0 up to 1 of x power 3 plus 1 times x to the power 3 minus 1 all over. Now you can see the common factor there is x plus 1. And then the other bracket must contain x cubed minus 1 dx. There you have it. This expression cancels that. And so what we have now is we have the integral from 0 up to 1 of x cubed plus 1 all over x plus 1 dx. And looking at the numerator there, we have what we call the sum of 2 cubes. We can factorize that numerator again and simplify. So we're moving on to page 2 and to just complete this one up now. So we're saying basically that what we have there now is that integral, this one that you see here, we move this one down so you're able to see it clearly. Okay, the pages are misbehaving. Let me put them in order. Right. So now, what I was saying is that is the same as the integral from 0 up to 1. Different sum of 2 cubes. Remember, up we have x plus 1 in one bracket. The other bracket must contain x squared. X times 1 is x. Here we have a plus sign. Here we must have a minus sign. And then 1 times itself. The answer is 1. Remember how you factorize the sum of 2 cubes. That's the approach. Because remember, 1 can also be written as 1 cubed. So this is what you get. So we have in the denominator x plus 1 and then we have dx. So you can see that this cancels that. And what do you have now? We have the integral from 0 up to 1 of x squared minus x plus 1 dx. At this point, I'm just going to use power rule to evaluate this integral, and then we are going to take the limits from 0 up to 1. So this is the same as, remember, power rule, x power 3, I'm adding 1 and I have to divide. Minus, the power here is 1, I add 1, I get x squared, I have to divide. And remember, this is x power 0, 1x power 0, and we add 1 and divide. The answer is just going to be plus x. Let me explain that one because someone may not see it. I'm basically saying that the integral the integral of 1 with respect to x. This is the same as the integral of x power 0. We're assuming x is not equal to 0 dx. And what does the power rule say? It says x power 0 plus 1. Take this, divide. And what is this? X power 1 over 1. And what is this? X. That's how I get x from this one here, which is the last part there. And we get x. What are our limits of integration? 0 up to 1. Right, punch in the 1 first. So we have 1 cubed over 3 minus 1 squared over 2 plus 1. And then we have to say minus. Put 0 in there now. 0 cubed over 3 minus 0 squared over 2 plus 0. Like that. Simplifying this, you agree with me that this is just 1 over 3 minus 1 over 2 plus 1 minus 0. Now this part, if you simplify this, I am going to say that add 1 to this, if you like. So it's going to be 1. You can also write it as 3 over 3 plus 1 over 3 minus 1 over 2. You agree with me that this is the same as here. It's 4 over 3 minus 1 over 2. We can say our common factor is 6. 3 into 6, the answer is 2. 2 times 4, 3 into 6, the answer is 2. 2 times 4, it's 8, minus 2 into 6 is 3 times 1 is 3. And our final answer is 5 over 6. That's our final solution to this definite integral that we have been looking at in this video, which is this one here. So from this integral, you learn something very critical. Do not rush at looking at other techniques of integration. Start by looking at the two expressions. If you have a fraction like this, look at the numerator and denominator. Can you simplify it? Can you factorize and simplify? That would be the first point to look at. And if you cannot do that, then think about other techniques of integration that you can employ. All right, so in this case, we had to do a little bit of algebra there, simplifying the numerator and the denominator, and then obtaining something that was very easy for us to work with. As you can see in here, there, and evaluating this, no use substitution whatsoever. We have just used power rule there after simplifying. All right, I hope you found that useful. Tell me what you think about this integral. Like I always say, your feedback is absolutely important. All right, I'll see you in the next one.